Welcome everyone. In this video, we'll discuss continuity of a function. So first I'll define it mathematically. What do we mean by continuous at a point? You could also define continuity on an interval, but let's just discuss what is a continuity at a point A. So let's say the mathematical definition we like to use is we say that the limit of that function f of x as x approaches A is equal to the function value at A. So if the limit exists and it's some number L, the function value at A is also that some number L. So this is the way to say the function f is continuous at A. Now, if you want to memorize a non-mathematical definition for continuity, just think of there's no breaks in the graph or there's no hole in the graph to be continuous at that point A. So for instance, if you have a graph like this, something like that, that's continuous. Now, if you have a graph like this, for instance, let's say it goes like this, and then there's a hole, and then it starts right here. This is not continuous because there is a break right here. Another situation where a graph is not continuous is when you have a hole in the graph like this. So you can have a graph like that, something like that. So again, it's not continuous right here at that point A. Another situation could be when you have vertical asymptotes. For instance, if you have a graph that looks like this or that, and here you have the vertical asymptote. So this is again a case where the function is not continuous at that number A. Okay. All right, now we can look at continuity from the right, from the left, or the graph can be continuous. So here's a graph that we're going to discuss where the function is discontinuous, meaning it's not continuous. So we'll find x values, whether f is continuous from the right, continuous from the left, or neither. So if you're continuous, it's nice and smooth, okay? But if you're not continuous, perhaps you could be continuous from the right, meaning only on the right side, and the left side it's not, or it could be continuous on the left side and not from the right side. So here I see a break right here. So at x equals -4, this is not continuous at all. Now, let's take a look at the next place we have a break. So that's this one right here at -2. So we see that x equals -2. It's not continuous, but wait a second. If you look at closely, here this circle is filled in. So it can actually come from the left. And here the limit from the left side and the function value at -2, they match. So you can say that the limit as x approaches -2 from the left side of this function f of x is equal to f of -2. So because of that, it's actually continuous from the left side. So because it's not continuous, but it's continuous from the left. So I hope that makes sense. And the only reason it's continuous from the left because this is equal, okay? Now let's go to the next place where we have discontinuity. So nothing is wrong here. Now here is the next trouble. Again, we have a break. So again, the circle is filled in. So although it's not continuous, we can tell a continuity from the right side. Now the reason this is from the right side is because if you come in this direction towards 2, the graph is filled in at that point at x equals 2. So we can say that x equals 2, it's continuous from the right. So the justification for this will be that the limit as x approaches 2 from the right of the function is equal to f evaluated at 2. So it's only continuous from the right side, but it's not continuous at 2. So at 2, it's not continuous, but we can talk about coming from the right side, it's continuous. Now let's take a look at the last place we have discontinuity. So it looks like right here at 4. So again, there's a break. Looks like there's some kind of well, we have no idea what's going on here. It's just going to keep going down this way. In this direction, it looks like we can talk about continuity from the right side again, because this circle is filled in. So we have another discontinuity at 4, but it's continuous from the right. And the reason for that is because the limit as x approaches 4 from the right of this function equals to the function value evaluated at 4. So again, we have a discontinuity, but we can discuss continuity from the right or from the left. Okay, I hope this makes sense.